Hello again. So, I'm back. Want to record another video. This will be my second video. Yesterday, we created a mini GPT that can learn Shakespeare language. It's a character level model, same one that Karpathy created in his videos, but I coded it slightly different and I wanted to use it just to kick off a series of videos because I'm going to use it as a foundation to sort of perform different experiments and repurpose it into different things. Um, Today, I want to deploy that model to a virtual machine using Runpod, and then I want to scale it up just to see how it performs, how it can perform a little better, and then I want to turn it into a word level tokens instead of character level tokens and see how that changes the performance. And then after that, probably in a separate video, we're gonna repurpose the code into a vision transformer. So I'm back in my hot ass room in Thailand. Um, it's 10:30 a.m. right now, so it's decent. It's okay. But once the sun comes out, it's gonna start baking my ass. So let's hurry up and get started. So last time I didn't show you how to download the code. It was I think I have it in one of my actual notebooks. It's in Karpathi's video too. I mean, it's just, but just for completeness, I'm gonna include it in my code if Jupiter starts. Uh, okay, here you go. So I'm gonna clean up my repo. I'm gonna clean it up for folks. Yeah, here it is. This line right here. So if we go to, where am I? It's in old already. So transformer. Wait a minute. Oh, okay. I think this is it. No. This is it. I called it language modeling 2. I should call that language modeling 1. Or just language modeling. So I'm just gonna add this as a comment. actually. Yeah, this will be fine. So folks know that. So showing how to download the code or the data. Okay. We can keep this open. Yeah. So, all right. So let's show how we're gonna scale this up. We're gonna use Runpod, so you can create an account, add some credits, go to pods, deploy. I'm gonna use an A100. It's I'll use there are two versions, SXM, which is slightly faster, I think, more optimized. I'll use the cheaper one. It's 164 an hour. Um, I'm gonna add a little bit more to the volume. I actually don't know how much volume we need, but just in case, we shouldn't need that much. I'm gonna install mini Conda instead of Conda. Conda can actually take up quite a bit of hard disk space because it installs a lot of libraries with it. So I'm gonna use mini Conda, change template. Wait, this is PyTorch. I'm gonna use PyTorch 2.4 because that's the version I have in my requirements, and I'm gonna add, I don't know, 40, I don't know, let's just say 50 gigabytes of volume disk. So this is an attached, a mounted volume. There's the container, the Docker container that has a certain amount of space here. I'm gonna add to the mounted volume. Of course, you have to pay extra for this, but it's fine. I'm gonna destroy all this when I'm done in 30 minutes to an hour anyway. So set overrides, deploy on demand. There are now, I imagine there might be better services than Runpod. I don't really know. This is what I used when I was working. Well, when I was working for Amazon, I used AWS, but AWS is way too bulky. When I was working for a spotter, I used different services. Runpod was one of them. I found this to be pretty easy to use. So GPUs won't always be available, but for the most part, you also have to set up SSH. There are instructions in the settings. If you go to settings here, in your account, there are instructions on how to set up SSH. I just use this first. I click this, copy this. It should be ready. I don't need this notebook anymore. Kind of deactivate. Clear. Let's close this down. Okay, boom. I'm SSH then. CD. Where am I? CD. Projects. Language modeling. So in here, I have instructions on how to set this up on Runpod. Make sure these are up to date. And then I have some scripts in here. So first, let's update. Let's copy this. Update apt, then install Vim in screen. Vim so we can edit files directly on through this terminal, through this SSH session, and also screen so we can detach from a process and let the training run in the background. Then we're going to install GitHub client so I can clone the repo. I'm sure there might be better ways to do all of this, more efficient ways. I haven't really thought through it, to be honest. I just want to get things up and running, and it's good enough too. It's good enough to just kind of get the job done, illustrate the point. So GitHub client, cat, oh, cat install. So we're gonna run all right, so let's go into the workspace. So we're gonna workspace is where the workspace is the mounted the mounted volume directory. So this is the path to it. Boom. So we're gonna say vim install github.sh ch mod plus x, make it executable, run it. Now where's the readme? Now we're going to, all right, we have to log in to GitHub. So gh, yep, so gh auth login. You can also clone without using GitHub client, but it's just easier instead of having to set up SSH and stuff like that. I just think it's easy to just authenticate. Log in with the browser. Actually, yeah, I'm just gonna copy. I think I have it right here. I already have, so if I type in device, signed in as JB the Jedi, authorize. Okay, we are good to go. Now it should push. Okay, boom, logged in, GitHub repo, clone, language modeling, boom. Should be the same. Copy the repo. Yes. So do I have screen? Yes. Good. So now we are going to, okay, install Anaconda. I want to install Miniconda. Anaconda's too big. You don't have to install Anaconda. You could just install all your libraries directly into Python, native Python, but I just think it's cleaner to install Conda, make virtual machines, just in case you mess up. I'm also a big fan of poetry. I should make a poetry file and define things, but it's fine. I'll just stay with this for now. So I want to install mini conda. Actually, I put the where did I put the instructions? Install mini conda. Cat install mini conda. Okay, so that's chmod +x install mini conda. So what does this do? This makes a directory. No, I should edit this. I should edit this because I want it to be under workspace. Make the directory workspace. Workspace. I think that should work. Okay. Root workspace. Oh, shit. Let's see what I did. It's using the tilde, the shortcut. Okay. Which is referencing root on this machine. So where did it install? It installed to root workspace mini conda. So LA root workspace. Okay. RM RF root workspace. Let's kill that. Let's vim, get rid of that. So mvim install mini conda. Okay. Workspace mini conda. Workspace. 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 I'm using my iPhone as a hotspot because I have no internet in this room, so this room is a hotspot because I am sweating balls. Git pull. Oh wait, no, it's gonna git restore. Shouldn't be initialized yet, but if I do mini conda, then conda should be the command in it. Should source boom. Okay, so I just called I found the root installation of conda. I called conda init, which modifies the bash rc in your home directory so that conda will initialize on startup, and I just sourced the bash.bashrc. Now we can do conda create -n. Also, this is all in the mounted directory /workspace, so that when Runpod shuts off, it doesn't, if it shuts off, anything that's not in the mounted directory will get blown away. So conda create -n language, let's call it lm. Oh, Python equals 310. Yes, this should all be much faster than using conda too. The installation is much faster. The installing conda, Anaconda, takes a really long time. We're gonna go to our project directory, which is cat requirements. We should get status, git restore, install mini conda. And let's go here. Let's go to our requirements file. Let's add tqdm, git add all, and git push. Actually, you know what? We can chmod +x install mini conda. Two requirements. Come on, hotspot. Git pull. We should see it as an executable. Nice. Cat requirements. Nice. Conda activate lm. Pip install -r requirements. Boom. Let's go. Okay. Am I still in the camera? Yes, I am. I have a large head. Okay. Ignore. I don't know what's going on here. Quit. What's next? What's next? So we installed mini conda. We installed screen. Wait. I should do. It should be like this. Yeah, I gotta clean this up. Gotta clean this up. Using. Okay, there you go. Looks like that's all done. I have a lot of pushes to this. I should squash at some point. Okay, so yeah, looks like. Okay, so, ooh, I know some things in my code that I didn't do. I need to send some things to the device. Let's let it complain first so we can sort of illustrate a point. So I need to send the data to be generated. The data that we're going to generate, the tensor that we send to the generate function, we need to send it to the device. It's going to complain, but let's let it happen. So what are we doing now? Let's go to practice, video practice, old, I put the files in old. We were doing language modeling, and we're doing video practice. Sorry, we're doing language modeling and transformer modules. So if we just call Python language modeling right now, it should fail because I think it'll fail because on generate because the data wasn't sent to the device. Let's see what happens. Oh, right. Also, I don't have the path to the data is different. Ideally, we'd have an environments file, and then we'd switch where the path to the data based on which environment we're in, but I just want to get this running right now. So the data is here, input txt. Typically, you don't want to install data. You don't want to store data in your GitHub repo, but this is fine. This is not like production code. This isn't like I'm not working for anybody. It's not, it's not a big deal. The data file isn't that big. If the data file is really large, you should just have instructions on how to install it, but not actually put it in your repo. So this is why I installed VM, just in case I needed to modify something. Let's see. Huh. It's saying no such file or directory. Oh, right, because I moved it into old. Let's do this. Just to keep everything the same as yesterday. Let's moving the files back to the parent directory, just like I was. So it's the same setup that I was working with in the last video, except I did change the file names. In the future, I'm going to be better about being more consistent with these things. I also didn't do a dry run of this deployment to Runpod, so but I think it's also helpful to kind of see me work through these problems, that these very simple problems that you're going to have when you're deploying to different environments. Um, Git status push git status git pull. Now we should see the files here. Now when I do Python language modeling, it shouldn't fail on that file, but it should fail on the data. Expected all tensors to be on the same device, but found at least 2 devices. So by default, everything will be, the data will be on the CPU, and you have to manually, even if your device is CUDA, your device variable is CUDA, you have to manually send it to that device. So I'm pretty sure estimate loss. Yeah. So let's change it here on my local machine. MVim language modeling. Boom. Estimate loss. And then also we need to do the generation. Am I still in the camera? Yes. So generate dot to device. Okay, I'm pretty sure that's it. So device for estimate loss and the generation. Okay, the back of my neck is sweating. Like, I'm fine here, but there's like sweat on the back of my neck. That's fantastic. Yeah, let's drink some more coffee. Okay. Did I push? No, I didn't push. Okay. Okay. Let's see what happens. Language modeling 61. Did I pull? Let's see. Did I send the model to the device? No. Model dot to device. Also the positional embeddings. Where am I? Oh. Let me run this locally. Make sure it. Okay. Yeah, that was the correct device call. Adding, sending model to device init, positional embeddings using device, get push, get status. Let's see what happens now. It's training, so let's see. Also, I want to see which device it's using. So one more print device. Also, let's just print seed. Oh. Okay, we're using CUDA. Cool. So let's wait for this generation. Am I still in the camera? Yes. Still in the camera. I should have decreased the number of iterations, but it's fine. Let's just wait for this. .3. So now we're going to scale it up after this. Hopefully the generation works. It should, because I did send the input tensor to the device. If I hadn't, it definitely would have failed. Boom. Look at that. Now let's see if we can scale it up and get some even better language. So if we say Vim language model, let's go to this config file. Let's give it some line numbers just because they look cool. 15, let's go halfway. Okay. Number of heads. So first of all, n embed, let's say, I don't know, 256. And then I think 16 times 16 is 256. So 16 times 10 is 160. And 16 times 660, 636, that's 96. So that's 160 plus 96. Half of 90 is about 50, so that's 256, yeah. Wait, let me just confirm that. 16 times 16 is 256. All right, let's get out of there too. So, okay. So, if n embed is 256 and I have, how many heads do I want? So if I have 16 heads, then the head size will be 16. And if I have half of that, 8 heads, then it'll be times 2, which is 32. So I'll have 8 heads. That'll be 32 dimensional attention head embedding. Number of blocks, I don't know, let's say 4. Or I don't know, let's say 6, why not? We're scaling up. Ideally, we do this iteratively. Yeah, how about we do it iteratively? Let's mess around with some things. 256, and then we'll combine these two together. So not really a controlled experiment, but that's okay. Actually, you know what? Fuck it. Let's just scale this thing up. 6, context window size, 32, batch size, 32. Actually, context window size, let's say 16. So this is context window size. You're increasing what the number of tokens you're conditioning on. So you're giving it more context, which should greatly improve its ability to model language. It's happening. There you go. So we can see it's a lot slower. Of course, if this was on the CPU, it would be very, very slow. It wouldn't be able. The performance starts to improve. It has a greater than exponential toll on the computational cost as you start scaling these things up. So what performs decently well right now on the CPU, we increase the context window size to like 32, and it's like, see, look, 1.97 already, the loss after only 700 training iterations. Actually 500 probably. That was after a 500 update because eval iter is like 500. So let's pause this recording and then come back to it once it's trained. Okay, so we're back. And here's the output for the training. I didn't print the final loss, but it was pretty low. It was a lot lower than it was before. But we can look at the language. We're starting to get actual words now from with this none, while, meaty, I'll, not, honest, radius, right, as opposed to this before, which is we don't even have words yet. So we can see that scaling up the model is absolutely improving things. I hit numbers on accident. And so the next thing I want to do is turn this into a token level model. So I put some code here. So we'll need to use NLTK to tokenize. I want to turn this into a word level tokens instead of character level tokens. So you'll need to add NLTK to tokenize your to word tokenize the data, the text. So, and then I'll get rid of that line. We'll just leave it commented. And then so now we need to create a dictionary based on the tokens. And we need to encode the tokens now and not the text. And I think when I'm printing the decoded text, I need to add spaces now because space is not a token that's anymore. So the model doesn't know how to output spaces, I believe. Although I could do that. It's just the way I'm tokenizing the words. It's not part of the vocabulary. So let's run this locally. Actually, let's copy CP language modeling word level.py, and then so let's cat language. Yeah, it looks like the space is there. Okay. And let's run the old file just to make sure it still works. Yeah, that's good. And then let's run the word level and see what it outputs. So we can see the loss is a lot higher because our vocabulary is over probably like 20,000 words. I don't know, like what's, I don't know, what did our loss start at? 6 point something. It probably started at a lot higher. ln x equals, I think it's 9.9. I think I did this already. Yeah, like 20,000 words or something if we're going to solve that. So let's see what this outputs. Looks like we don't have proud they laid up by me God their institute. It looks like it doesn't have yeah, it looks like, I mean, it can obviously produce words, but a character level model producing coherent words is a feat, but a word level token model producing words obviously is axiomatic. So we would like to see coherent sentences. I wonder if coherent sentences is analogous to coherent, is a word level language model producing coherent sentences is analogous to a character level language model producing coherent words. I wonder if that's analogous, but interesting question. But let's deploy this. So git status. Let's scale it up on our Runpod using the A100. Git add all. Is my hotspot still on? Yes. Git pull my recording. I am. What variables did I use? $16, $32, $256, $8, $6. Oh. So now let's run this scaled up word level model. Run it again. Should work. Okay, I guess it's the first time. Okay, yeah, okay, that makes sense. All right. All right, so let's pause this, I guess. Well, let's see what the first. Let's make sure it runs first. Loss starts at 10.1, so there's. Let's wait for it to update, and then we'll pause the video and come back. $5.2. Yeah, okay. Let's pause the video. So we're still training. It looks like the train loss is significantly less than the validation loss. I don't really have a reference point right now. I need to do more iterations and do some plots. But from what I've seen so far, it looks like it's possible we're not learning too much more. I don't know. I want to see it step down one more. See what happens. But let's see. I did want to mention something else. Yeah, it's going up again, I think. So it looks like we passed the optimal point. Maybe we should have done some early stopping, but I'm sure I can mess with the hyperparameters more and understand why it's not learning well anymore. But anyways, I wanted to mention in Karpathy's original videos, he implements layer norm and he puts a 1 here for the dimension that you're normalizing over. It's supposed to be -1. He puts a 1, and that's the batch token. So the shape is batch token, and then D for the dimensional size of your token embeddings. If you put a 1 there, you're going to normalize over your token embeddings, and it's going to get it. You're going to get an error. So I think this is supposed to be -1. Just FYI, I wanted to mention that. So yeah, the validation loss is definitely increasing. So I wonder what it's going to generate. Was in good age for his sake, Lady Capulet. I am Lucio, like an oath by my soul that I mean, with mine own tongue deny him. Why? Clarence, be patient, as if this by the ears, by the swords, in anger of the fair, he will, gentlemen, to the forthwith of this man not to be touched. So it's like, yeah, it's getting the feel. It's really getting the feel of this Shakespearean. Even though the train loss kept going down, right? So like typically, like your plot will go like it'll be like really close, and then it'll boom, and then validation will start to go up, and you want to stop. You like the optimal model is like right before, right as it starts to climb, right at the called the knee or whatever of the validation loss, where it starts to, you know, where the curve starts to change by a certain rate relative to itself or something like that. Um, but yeah, this is still cool. So, anyways, there you go. We deployed the Runpod. We used an A100 to scale up the model. We changed the token level model to a word level model. And I did mention about the layer normalization dimension needs to be -1. Yeah, I think this is pretty cool stuff. So next video, we're going to we're going to repurpose this code, basically use the same transformer code, and we're going to modify this language model to work with images. So we need to add a class token. We need to change the position embeddings. We need to add patch embeddings. And then we're going to use that to classify some images. And then we're going to build that from scratch, and we're also going to build ResNet from scratch and compare a vision transformer to ResNet 18. And we're going to talk a bit about inductive bias. What is inductive bias? Why does a model like ResNet 18 have more inductive bias than a vision transformer? And what does that mean in a practical sense? So anyways, I'm going to go to the beach now, take a little bit of a break, probably do some video editing later. Thanks for tuning in. Make sure to like and subscribe, and just please leave some comments as to what you would like me to explain more, what you found interesting, any questions you have. Yeah, thanks. Later.